everybody, good evening, good evening. Welcome to episode 82, Tuesday Night Live. Appreciate everybody logging in. Seen John's in. Hey John, how you doing? My buddy Rick, he's in. I don't know if Ryan's on yet, but he gave me a nice post and shout out on his Facebook thread, I guess it's called, or whatever, post. So that was really nice of him to do that. Catch up with guys a little bit what's been going on over the last week since we were on live last week. We picked up Dave and Kim Chevelle from the paint shop. They got it all buffed out and all the chrome put on and all that. It's in my trailer still. I didn't get it out yet. I have a couple little things I want to touch up on it, and then it heads over to the upholstery shop. So we'll be getting a wrap-up video on that car soon. And yesterday, Matt came over from Tampa and picked up his 351 Windsor. It's something that I built for him, and we kind of what prompted the last week's show and this week's show. So that would be good. He's all set. Everything's primed and timed, and all the valves adjusted and ready to drop in his truck. So good luck to him in getting that done, and we'll see that in the future to do some tuning on his Terminator. And starting on my buddy Scott's 8.1 big block. So I got to get that built for his Allneck C60 Chevy race car hauler, vintage race car hauler. So I think this week we're going to work off of the 351 Windsor for a short block video, and we'll hopefully, if I can get that 8.1 put together before next Tuesday, we'll do the top end off of that engine. So we'll just kind of, like I was saying last week, try to spread this thing out over a couple different nights. Engine blueprinting and assembly. It's quite a bit to talk about. Something that a lot of people may have done some engine repair or put an engine together, but probably did not blueprint it, because it takes some tools and specialty tools and some knowledge. So that's what I'm trying to give you guys, a little insight on what you kind of need to get it done, and why you do it. Making sure all your clearances are proper. Machine shops will do all the work, the boring and honing, square decking, line honing, all that stuff. Sizing, connecting rods, what have you. But it's the engine assembly person's job to check over all that work and make sure it was done up to snuff. It's done correctly. That's what's going to give your engine longevity and be able to make the most amount of power and efficiency that it can possibly make. Having all those clearances and all that will reduce drag, reduce wear, and of course, if you've reduced wear and drag, you're going to make more power. So those are the reasons why we do it, and just trying to take some of the mystery out of it. So over the weekend, Chuck was in painting his chassis. He's got the chassis just about finished now. So we're getting very close to being able to bolt all the suspension back on, get the brakes done, and then we just have to do the firewall and inner fenders so I can put the engine and trans in, and then we can start building the hot side and cold side for the turbochargers, and get that thing moving along. With the engine work that I did this week, unfortunately, I was not able to get much done to the T-type, so that project's kind of on hold, but we got to get back on that. I did ordered some more vinyl for the Cup car. I've got the new number 7s on the car, and it looks great, which then made all the other decals on the car kind of look faded and aged. So I reached out to Comp Cal Vinyl up in North Carolina who made the numbers for me, and they're working on getting some of the sponsor stickers made. I have some of them. Some of them my buddy Doug had sourced out before I picked up the car from him, so I have a handful of stuff already, but there's a lot of specialty pictures we have to get on, stickers we have to get probably made again, because they were like Busch Clash stickers and NASCAR official stickers and stuff like that, which usually the general public doesn't have. So I'm sure the Comp Cal will be able to make those for us. I see Bill's in. Hey, Bill, how you doing? So that's making progress. I am going to Amelia Island with the car in, I think, 3 weeks. So that'll be fun. This weekend, I did talk to Chris. I'm not sure about my buddy Chuck, but I think we are going to meet up at Sebring, and we'll cheer on my buddy Pat Utt, the previous owner of RaceQuip. We've been friends for probably 40 years now. He's got a TA2 Trans Am Camaro, and he's racing at Sebring this weekend, so it'll be a local race that I can go to and watch him. And along with that, there's a couple events going on at the same time this weekend at Sebring. So you have the SVRA, which is Sports Car Vintage Racing Association, and they run in, I think it is Group 10, they run NASCAR and ARCA cars on the road course. That's the run group that they race in. So I'm going to try to get some video of those guys racing, and obviously check out some of the cars and see what they got going on. I believe the race director told me they have 19 cars. So it was probably not a good event for me to take my car to, although it's not ready yet anyway, and I don't have a current license, so I couldn't have raced it anyway. But we're getting closer to that, getting closer. But that'll be good. And also, they have like a cars and caffeine or cars and coffee car show, and they also have the Optima Ultimate Street Car event there also, where they do the autocross, power stop. They do a not a cross country, but a city cruise, and then they do design and engineering car event, where they judge the vehicle for the way it's put together and the engineering that went involved with it, and the accessories that are there to make it a true street car. And then they also have a session on the road course. So a lot of things are going to be going on Saturday. I'm only going for Saturday, so I'll be running around trying to get some video action of all these things. But the Ultimate Street Car is important to me for the Vet Hawk project, because that is where that car eventually will be raced at. Initially, it'll do some local autocrossing and probably LS Fest, but before it goes to the Optima series, it needs to be fully painted, full interior, because you have to do the judging portion of the event too. So, it has to be 100% done car, or at least you would like it to be as close as it can be. So, be really good. I see Chris is on. Hey, Chris, how you doing? So Chris was telling me he went, I don't know, last year or 2 years ago, and he said it was very eye-opening, I guess. Maybe not eye-opening, but it was good to see what they do during the car judging, where they're looking for design and engineering. So you can see kind of how that all works, because you only have like 3 minutes to sell the judges on all the highlights of the car. So it's something that you have to probably have rehearsed and worked on, and obviously you want to show the highlights. Those are the kind of things I wanted to go see how that all works out, so that when I'm designing and engineering my car, I know to what things I can kind of put in and look for and stuff like that to do that. Anybody doesn't know about the Optima Series, the whole thing is you go to select events across the country, and you get scored from 100 to 0. 100 is the best in each category, and then whoever is the highest points holder at the end of the event is the winner in each category or each class, and then they get a ticket or an invite to SEMA for the championship. Now, of course, if the top place car has already gotten an invite, then the next place it's not invited gets the invite. Bad thing for us is that Sebring is the first event of the year, so there is nobody that's going to already have a pre-invite. So it'd probably be a tougher one of the events to get into the Sebring part. But it'll be fun to see how it's all done. I mean, the autocross and the power stop, the Optima Series is run by FM3 event planning, which is run by Jim. Wow, just lost his name. But he's the same gentleman, same organization that runs LS Fest. So the Power Stop and the Autocross are already events that I know how they lay it out. Most of a lot of the workers and stuff like that are all the same crew. So that'll be good to see everybody since the last LS Fest, and we'll get to see how they run this series. I'm sure it's run a little different, and of course they have a couple different events that they don't have at LS Fest. So it'll be good to see what's going on and go on from there, and we'll get the Chris told me that before. The technology in the top tier cars is insane. I mean, these guys are building top tier street cars that are raceable cars. That's the whole idea of this ultimate street car, is that it is beyond your normal car that you could ever imagine picking up from a dealer or anything like that. Obviously, if you're running the vintage class or something like that, obviously it's an old car, but the work and amount of time and effort that's put into these cars is crazy. I've seen some of the guys do run LS Fest if they're LS powered. So I've seen some of the cars. Mike DeSole has had his Camaro there before they changed the rules on that Camaro. But when it had the original 67 Camaro, they had a Corvette drivetrain in it, tube chassis car. It had the original camo paint, and then he had the snow camo paint on it. I think in 2001, which was the final year I think he ran it over there. Super fast car and unbelievably engineered and stuff. So they moved his car into a different category because they're trying to keep the cars fairly realistic chassis and stuff like that. That's one thing I had to check with the Vedhawk to make sure my car wasn't going to have any stigma, because it doesn't have a Vega chassis, but it does have a stock Corvette chassis, so it should be fine. I don't think it's going to be any problems there, and of course I don't think I'm going to light the world on fire where they're going to say, oh my God, look at that car, we got to pick him apart. They don't seem to be that way. It seems like a really good group of people, and so we'll see how that goes. And of course, the SVRA is going to run the stock cars, which, eventually my car will be put for sale. I'm just trying to get all the I's dotted and the T's crossed so that it is a legit road race car. So that's kind of a good thing to go up and scope out these guys. Joe Nemechek and his brother run this division for a couple years now, and they are really fast and really top drivers, obviously. And so it'd be good to see all the little nuances that they've done to these cars from the days that they were actually raced in NASCAR legally to what they're done now. There are some pretty strict rules about making modifications, so that's where I'm kind of want to see where the gray area is and what can be done, what can't be done. So it should be a really fun weekend, and hopefully running around I'll still be able to get plenty of footage to try to make a video on it. And of course I'll show you guys some of the inside stuff. So with that kind of catches everything up. I wanted to go ahead and I'm assembling the build video for the 351 Windsor for Matt's truck. But what I did was I took snippets of it to go to part 2 of our blueprinting and engine building. So let me go back here for a minute, and I kind of just do a little refresher on a couple things. So hopefully I check the volume, and hopefully the volume stays good here. But obviously you need micrometers for this job. You need to mic the pistons, the crank main journals, the rod journals, and then just showing on this slide how to zero it. And here's some of the some of the components that you use. You got a thimble, which is like a clutch. So that has it's preset for how much drag. So you could over tighten something and change the reading. You want to use the clutch so it has the same feel every time. And obviously a lock nut so you can read it. And then you need a dial bore gauge. And what you do is you set up your dial bore, you set up your micrometer, and then you do the dial bore gauge, and that then you can find out what your clearances are between your bearing insert and your crank journal. So here's a couple little video snippets. Feel free, if you see something, put it in the live chat, because I can stop these and we can discuss things if you see something you want to see more information on. And of course, if you're watching the video after it's been live on replay, by all means put something in the comments. So let's see. Let me get this all set up here. All right, so this is going to be on installing cam bearings, which a lot of people don't do. It's usually done at the machine shop. I like to do it myself because I like to make sure it's done the way I like it. So here you go. Now, in most engines, your cam bearings are different sizes. So when you open the box, they give you this little identification that tells you which bearing goes in which position. Obviously, this is 1 through 5. I have an older cam bearing tool. It actually uses solid pieces like this. The bearing sits on and you push it through. Now, one thing you have to remember is there's always an oil passageway, and it has to line up with the oil line in the block so that the oil can pass through from the cam bearings to the main bearings, or main bearings to the cam, whichever way that particular engine feeds oil. So it's just things you have to pay attention. The tool will push here and line up in the front, so it makes a dead center. That way all bearings are pressed in a common manner. And that way when you're all done, the cam will go in and it'll go real smooth. Once you have the bearing in place, you simply use the tool and knock it in. So once you knock the bearing in, you take a light and you light up the inside of the bearing, and you can look down the oil passage and make sure the bearing is centered in the oil passage, which this one is. Now on to the next one. Again, you use your light and look through to see if the bearing is centered, which it is. Check it, and again, we're good. Now, because we're getting to the front two, our front fixture is not going to be a good hold anymore. So now we're going to use the holder for the rear. We're going to stick that one in the back of the engine. And we'll use that for our alignment for the rest of it. So now on the second one, we're going to use a support on the fourth, and we're going to use a support on the first, and that will keep everything in alignment. Once again, we check in and make sure it's centered. Now we'll go to the very first one. So now we're going to do the first bearing. We're going to use the fourth one as our holder. So that way we got a perfect alignment when we're all done. So now on the front one, it actually has to be driven in a little bit farther. We can see through the oil galley that it's not quite in the center. And now it is. So the cam bearings are now installed. We'll stick the camshaft in and check to make sure it spins freely. Slide put a little assembly lube on the cam lobes. A little down the oil passage, put some lube on the cam bearings. Try to be careful not to nick up the, let the lobes nick the cam bearings up. A little more lube down the holes. There we go, cam is in. And it spins nice and freely. It's got some drag on it because we put some thick assembly lube on it, but it's nice and smooth and is ready to roll. So that's how we install the cam bearings, and now we can proceed with measuring the crank and bearings and get all the bearing clearances figured out and assemble the engine. All right, so there's the cam installation. See, Ryan made it in, hey Ryan? And you're right, you can hear the pitch change as you're knocking them in. It's funny, you got to use a lot of force because the bearings are a press fit, but you don't want to pound them real hard, so you just use a heavy hammer and a good repetitious hit with the hammer, because you don't want to scuff them as they're going in, or you don't want them to jam up. And the whole idea of that is, of using that tool, is when you want them done, you want all the bearings to be perpendicular. If one bearing is cocked, the cam will have a lot of drag on it, and then it'll obviously turn the bearing to copper, and then you're going to have a oiling issue. So something, like I said, I like to do it myself. Sometimes the machine shops will go ahead and install them anyway, but I do prefer myself. And using the assembly lube, it does put a lot of drag on it. That stuff is really thick. It's not as thick as the bearing guard that you use on the bearings, but way thicker than motor oil. If we put motor oil in there, it'd be loose, nice and loose and stuff in there. Now, of course, you could take a micrometer and mic the mic the cam journal, and then use an inside mic and mic the inside diameter of the bearing, and you know what your bearing clearance is. But it's really kind of hard to get the tool into all those. The inside mic I have is only about 12 inches long, so you could only get the first two because the gauge is too big to fit through the rest of it. So I was taught years ago from a engine machinist that was very professional and been at it for a very, very long time, that as long as the cam has a good feel, and it's something that you gain over time, that 99% of the time you are 100% perfect. It's very similar to checking the backlash on a ring and pinion setup, or checking the bearing preload on the pinion head. I do this all the time on those, is I'll test it by hand, and I'll think what my clearance is, and then I'll put a gauge on it and see how close I actually was, and most of the time I'm really almost spot on, so it works out really well. Rick says, are cam bearings different for different manufacturers? Yes. And they're not only different for different manufacturers, they're different for different engine platforms. Every engine will have its own particular camshaft. Now, like small block Chevy, all small block Chevy, Gen 1 and Gen 2 have the same cam bearings, and LS has its own cam bearings, although there's two versions of the LS. Gen 3 and Gen 4 use a different cam bearing. Now, it's not for the camshaft ID, it's for the bore OD of the block that the bearing sits in. You couldn't see in that video, but when you open the cam box on one of the flaps, there was too much reflective light in the video, but they actually tell you journals 1, 2 use this part number, 3 use that part number, 4, 5 use a different. So they actually, from the OEM, will put a different journal bearing, a journal diameter in the block. Now, when you get to race cams, if you're building a lot of big blocks, even small blocks, where you'll put a 55 millimeter bearing camshaft or a 60 millimeter camshaft, these are much larger diameter camshafts. And the reason they do that is because when you go, a lot of race engines could have 800 thousandths to over an inch of lift, and the lobe is just so big you can't get the camshaft in through a stock bearing diameter. Now, you could cut the base circle down, but the problem is then you take so much material off the camshaft that the camshaft will actually twist in the block. So you don't want to do that. So they increase the journal diameter, put a larger camshaft so the base circle can be closer to stock or even oversized, and yet still clear for the large lobe lift. Mike's on. Hey, Mike. And he says, do they have different hardness bearings for the cams like they do for rods and mains? There are a production bearing and a race bearing and a coated bearing. Those are basically your three types of cam bearings. But the sizing, as far as I know, they're all the same. I don't think you can get like a plus 1,000ths or under 1,000ths like you can on a rod and main bearing. So they're expecting, if the bore is good, then the cam bearings would be proper, because they're set for a certain amount of crush when they are pressed into the block. So once they're pressed, then you get that clearance is usually set up pretty good. So that's kind of how that all goes. I thought that'd be interesting. A lot of people, some engine shops don't even put bearings in. So just something to give you guys some information on how things are done and stuff. So the next part that I did on that motor was the main and rod clearances. Now on the mains, unfortunately, I lost that section of video, so I caught it after I already had the crank installed. So I kind of went over it during the rods. So you want to do that. Sorry about that. Hit the wrong button. Okay. Stop. I did it again. Okay. So let me get this all queued up here. So okay. All right, so this is the section on the rod bearings, mains, rods. So just to show how we measure bearing clearances, to go ahead and whatever journal we're working on, or even the piston, mains, rods, or piston to wall clearance. Anytime you want to know those clearances, you take your micrometer, put it on the journal, find the spot, and we got our measurement. This is 2-inch, 3/10.5 thou. Now we're going to take our dial bore gauge, stick it in the micrometer, locked it where it was at, and we zero it out. Kind of move it around in there to find the smallest spot where that's going to be where it's the straightest. And we have it zeroed out now. Now you don't have to do it this way. I like to do it it makes it easier to do it by yourself. But we put the piston and rod in a piston vise. We stick our dial bore gauge in the hole. We find the smallest reading. So that's 2/1000ths. We'll go right to there. You can see that's the smallest area. There's our zero. That's what the journal is on the crank. And that's where we're at, where the bearing clearance is. So we're at 2/1000ths rod bearing to crank journal clearance. So that is our bearing clearance. So we do that to all of the cylinders. All right, I thought that was the bearing clearances. I guess that was all the bearing clearances. So there you saw, measured the journal, and set up the dial bore gauge, zeroed the bore gauge to the journal diameter, and then put that in the bearing. Now on the mains, you would have the bearing torqued in the block with the caps, but no crankshaft, and you would do the same exact thing. You put the dial bore gauge in, read it, and whatever the minus side of the zero is what the actual film clearance or gap between the bearing insert and the journal of the crankshaft. So that's going to be your layer of oil when the engine is pressurized. So now that is the part where you can get different thickness bearings. So a lot of the, like I showed last week, the manufacturers will have a plus or minus spec for their crankshaft journals because they're mass produced. So they're not all going to be spec on. I mean, they may make 500,000-600,000 crankshafts a year. So to get them exact for one engine model, and they're doing multiple engine model platforms and everything else, it's too hard, and they're not charging the money. Even though new cars are very expensive, but you're not paying for custom built engines. So they have a plus or minus spec that they go by. Now, when you go to an aftermarket crankshaft, now you're paying a lot of money for a piece. So they want to be a lot more critical on the sizing. So they will usually be spot on the larger diameter of the factory spec. So what can happen at that point is if you have a block that's on the tight side, still within spec, and you have a crank that's on the outer side, the bigger side of that factory spec, and you put a standard bearing in, you're going to have a lot less clearance. Now, again, on the factory engine, they will have a window of clearance that's a go, no-go. And it'll be quite a large range because they've already done their testing. They feel that the tighter number is sufficient and the larger number is below their wear spec. So that's where they go by. Now, obviously, on some engines, it's not very good if they're really tight. Mike can attest to how many engines he's been replacing for bottom end bearing wear. When everything's very tight, it becomes very critical. Startup, oil changes, things of that nature. So obviously the consumer doesn't care. They hit the key, they fire it up as soon as the car lights, they drop it in gear and they're gone. Well, if your engine is on the tight side and you're going to drive it in that manner, you're probably going to eat up the bearings. Now, it's the manufacturer's job to make sure that their minimum spec allows for that. Now, sometimes they miss it. So in that case, you're going to have engine warranty issues as Mike is seeing. So, but for us, for performance motors, we don't want anything on the tight side. So what you can do is, if you watch the engine build on the Cup car, I was 2000s on the rod and mains, and I wanted more clearance. So what do? I could have the crank polished and get some of it out, but it's going to take a lot of work. And if you're polishing, you're just sanding on the journal. It's not like grinding it. So it's not as exact keeping the journal round because there's a lot of things that go into it, pressure and speed and all that stuff. And a crank grinder is usually not in anybody's normal area. That's kind of a specialty thing. And for them to take a half a thou or a quarter of a thou off, you're spending a lot of money to do that. So what you do instead is you buy a 1 thou undersized bearing, and you can stick that in, see where that ends up. And if that gives you too much clearance, well, then you do a standard and a half thou, one of each shell, put them together, and now you've got that gap, you got that clearance exactly where you want it. Mike says, but they don't make a harder bearing or softer bearing for different uses. I remember seeing king bearings in different. Yes. So you're right, Mike. So I don't necessarily think they do that for cam bearings because that's kind of a unique device that really doesn't have any load except for the load of the lifters pushing on the load on the cam lobes and how tight the timing chain is. But now on main and rod bearings, there is completely different bearing makeups. There's each manufacturer may have 6 to 8 different layers. So a rod bearing or a main bearing has multiple layers in the bearing itself. Layers of babbitt and copper and sometimes steel and other materials. And then they have coatings too. So typically your street bearings are all going to be fairly, no matter whether it's Cleveite or King or Malley or whatever bearing you're going to use. Typically the street bearing is very similar in construction as the OEM bearing. A lot of times it could be even the same bearing. I believe most of the GM bearings are made by Cleveite. So their street bearing and the factory bearing are probably going to be exactly the same. Now, as they get into different designs for different applications, they'll get different makeups. So now, I'm sure everybody's heard of Clevite 77. Well, the Clevite 77 is their performance longevity bearing, and the Clevite 77 bearing is a very hard bearing. When that bearing makes a touchdown and you start to get a seize in the bearing to the journal, it gets ugly fast because that bearing turns straight to copper, and very, very little layer of babbitt to be the protectant. That wipes off. I've seen engines that just had dirt in the engine, went from building or from not lack of oil change or whatever, where they'd already cut, the dirt has cut through the babbitt and gotten into the copper on a Clevite 77. Now, King is another bearing that I use a lot of. King are typically, their performance bearings are more of a softer bearing. They have a lot thicker layer of babbitt, and then they'll go aluminum, and then they'll go to the copper and whatever other materials they make up. So they can take a lot more touchdown abuse. Obviously, you never want touchdown because you're going to get metal transfer, you get heat, and it just ends up in engine failure. So, but they do have some different, properties and different makeups. A lot of these bearing manufacturers now on the performance bearings will sell a coated bearing, and the reason they put the coating on there is not for touchdown or anything like that. It is made to wear away as the engine is breaking in on the first initial couple starts, because their theory is that people don't check the bearing clearances enough and they don't clean the engine enough. So they want that babbitt, that protective coating layer, to almost be like a lubricant to break the bearing into the surface on the crankshaft. Ryan says you have to be on point with those bearings. They are not forgiving. You are 100% right. If you have a bearing issue in your engine, you have a big problem, no matter whose bearing you use, plain and simple. And the reason why they have different layers of material in the bearing is because the bearing has to be stiff. So when you put a bearing into the journal, whether it's a main cap or a rod cap, you'll feel that you have to actually push it in. It's actually got, it's actually a little hair oversized in its shape so that it locks into the journal. When you lock the connecting rod cap to the rod or the main cap to the block, that crush is made to hold that bearing in place. Another good point is you never want to have a lubricant between the bearing and the block or rod itself. It needs to go in dry. They're looking for that friction to hold that bearing tight. So if it does make it a very short, uneventful touchdown, that it doesn't grab the bearing and spin it in the bore. Once it spins in the bore, now not only do you have a damaged crankshaft, but now you have a damaged block or a damaged connecting rod. And a lot of this stuff, your LS engines on the factory rods are what they call a breakaway rod. They actually, or snap brake, there's a couple different terminologies, but they actually put it in a machine and snap the cap off of the rod. And so it has a valley or waved type shape to it, and all the metal particles are exposed, so it's very coarse, so it locks together to hold the cap and the rod together very stiffly. Now, of course, your block will have steps that the main cap registers that the main cap tightens down into to hold that tight. So the bolts are there to hold the crush, but the design of the block to the main cap and the design of the connecting rod caps are to hold from side to side movement. You don't want the bearings to shift, because obviously that's going to create a bearing issue. You get into aluminum connecting rods and a lot of your performance steel connecting rods, they will actually have a pilot or a bushing in there so that when the cap goes on, it slides over that bushing to make perfect alignment. Aluminum connecting rods, racing connecting rods, will actually have like teeth ground into it, where you would have R&R have like I believe it's R&R has the circular, and MGP has a curvature tooth, basically teeth, that interlock each other when you torque the cap down. So all these things are done to try to prevent the bore that's holding the bearing from distorting, because then you've got a mechanical issue that causes the bearing to touch down and destroy the engine. So they do everything they can to stop that. So what we have to do is check our clearances, so it's not a clearance issue that causes that problem either. Now, if you run the motor low on oil and you have air going through and you lose oil pressure and it has a touchdown, well, I mean, that's on the operator. There's nothing we can do to prevent that, except for maybe putting an AccuSump or something like that on, but that's beyond the normal realm. But so that's the whole thing. The whole thing with bearings, you want to make sure that they're all good, and you know, on main and rod bearings, you definitely want to think about the build, what the build is going to be used for, so that you can get the clearances and the proper bearing design for that particular build. Now, like one thing is, if you're using aluminum rods, you have to have a dowel hole drilled in the cap side, because the aluminum isn't strong enough to hold the bearing in place by the tabs, because it's in the aluminum. So the bearing is actually stiffer than the rod is. So they put a dowel pin on the cap side of the rod to hold the bearing still. If you have an aftermarket crankshaft and it has a big fillet in the corner, a big radius between the throw and journal, you have to have a narrowed bearing, because if the bearing is touching the radius, you've got touchdown. So these are the things you have to kind of think about as you're putting the package together. If you're buying a crankshaft from a higher end crankshaft from a manufacturer, you speak to the tech department and say, what bearing numbers should I get for this so I get the right width? If you guys look at the 4200 engine build, you'll see where I actually had to build a fixture, because we're running a connecting rod that does not belong in the engine that it's intended for. So that motor has small block Chevy rod bearings. Well, Chevy rod bearing is made for a radius on one side and then two caps for each bank ride in the center. So the bearing is full width on one side and radiused on the other side. Well, now that the rods are in a 6-cylinder and the 6-cylinder has one rod per throw, it needs to be narrowed so that it can not touch the radius on either side of the bearing. So in that video you saw I had to make a fixture and actually narrow the bearings down to fit in the block and not touch the radiuses in between on the connecting rod between the throws of the crank. So these are all little things that when you're blueprinting the engine, that's what you're looking for. You're trying to catch this stuff before the motor goes together, so that when it goes together, it stays together. So the next thing I did was pistons. So let's bring that up. So here's the piston section. All right, so now that we have the connecting rod bearing clearance set, we want to do the pistons. So in the instructions, it shows to use that spot there on the piston as your mark, as your measurement. We take our caliper, slide it on there, turn the clutch till it locks, and the piston diameter is 4-inch 029, 30 over piston. So now that we have that, we'll put our micrometer in the vise, take our dial bore gauge, zero our gauge. Now with the gauge 0, we'll stick it in our block and we measure our clearance. Measure it in a couple different positions. And we'll take those numbers and write them down. And we'll measure each piston individually and then read each cylinder. So we just read piston for cylinder number 5, and it shows 2 thousandths piston to wall and the manufacturer calls for a minimum of 1.5 thou. So we're a half a thou oversized, which is perfect. Now the next thing we will do is check our ring gap. Alright, so I like to use this tool. It's a ring squaring tool, so you put it in the cylinder and it makes the ring perfectly square to the bore. So we'll take our top ring, stick it in the bore, use the squaring tool. Now we'll check to see what our gap is. Now that gap is 16 and we want to be 20, so we're going to have to file fit the ring. So now we're going to do that with the top and the second ring for each cylinder, file them to size, then put them with the appropriate piston and then install them in the engine. So we're going to do that now. Now that we have all of our rings filed, we're going to go ahead and install them on the piston to prep them to put it in the engine. So I like to put the rings in a little saucer with a little bit of oil. I use Joe Gibbs break-in because it has special lubricants for aiding in ring break-in. First we put the expander ring in. Make sure that the expander is not overlapped. Wipe off the excess oil and put the oil scrapers on. Put them on in opposite sides. And we'll flip the piston over and go to the next one. Wipe off the excess of oil. Now to put the piston rings on, when I did the oil scrapers, they're very flexible. You can twist them around and add them on. You can do that with your second and top ring. However, being they are much stiffer and thicker, you run the chances of putting big gouges in the sides of the piston skirt. So I prefer to use a pair of ring expanders. Find the piston, the ring denoting top. You just spread it out till it goes on. Flip the piston over again, we'll go to the other side. Again, we use the expander. Go 180 from the second ring gap. Put it on. Now we're ready to put the piston in the motor. Now you can use different type ring ring compressors. I like to use a tapered ring installer. It works really nice. Again, lubricate it with a little bit of Joe Gibbs break-in oil. Slide your piston through. Center up the rings. And now this is ready to install in the engine. So one of the things I like to do before I install the pistons is clean the cylinder walls to make sure I have all the chemicals out of all the oils and residue, machining grit, all these things out of the hone of the cylinder wall. So when you hone the block, it's not perfectly smooth. It actually has some grain in it. That's where the rings are going to seat. So take a little clean white rag, a little lacquer thinner, and I'll clean the cylinder wall with it. Now remember, this block had been cleaned by the machine shop, then I cleaned it, with soap and water and a bristle brush. And then I sprayed Fog It so we could have the engine could sit without oil on it, so it won't surface rust until we're ready to assemble the engine. And you can see how much stuff came out of the block. So I'll do a second coat around it. That one was pretty clean, so we're ready to go. Now, before I install the pistons, I'll go ahead and put a light coat of Joe Gibbs driven braking oil, because the braking oil has a lot of properties that help aid in ring seal. That's the main thing. The first 500 miles, you want all the ring seal you can get. That'll stop blow-by and make the engine have really good compression and good longevity. All right, so we went ahead and put our Joe Gibbs driven braking oil on a rag, and we lubricated our cylinder. We're going to take our connecting rod, and you'll notice, if you ever wonder where a connecting rod goes, there's specific places. So if you look, there's a taper. There's a taper here, and on this side, it's smooth. So on this side is where your opposite cylinder connecting rod is going to lay, and the taper goes towards the throw of the crank where there's a radius. So on the driver's side bank, the radius is going to go towards the back of the engine. We're going to take Cleveite assembly lube, bearing guard, put a generous amount on the bearing journal. I'm going to use this Powerhouse product connecting rod guide. Throw that over the journal. Get that lined up with the connecting rod here. We're going to put our extensions in. Hook it up to our guide there. Put our piston in the appropriate cylinder. And with the ring compressor, you just push it in. Take our piston hammer and just give it a couple light taps. Now the piston is in the hole. We can push it all the way to the bottom. Now the reason I have the engine turn on its side rather than pushing them straight down is because now, since the motor's on its side, we can now see what we're doing for the alignment for the bearings and stuff. So we'll take our guide, connecting rod guide off. And of course, there's tabs on these caps, so the tabs have to line up with the tabs on there, also with the offset. But this way, when we knock the piston in, we can make sure that the bearing hasn't shifted, and we can look at it. When you're pushing the piston straight down, now you have to look upside down to see if everything's in the right orientation. It makes it kind of hard to do and very simple to make mistakes that way. So we'll take our bearing guard. Nice thick coating. Line it up properly. Push it together. And since we're using stock rod bolts, these just take a little dab of oil. And we screw it together. I like to snug them down with a hand wrench. And then torque it to the appropriate torque spec. And then I like to spin it around so you can feel if there's any drag like if a ring got out of place or anything else. If it feels nice and smooth, it's time to go into the next one. So we'll do that 8 times for all 8 cylinders, and the short block will be assembled. All right, so that was the installation of the pistons. I didn't get into a couple things showing the ring filing. That's something we can do in a future show. Gave Joe Gibbs Racing, Joe Gibbs Driven Oil, big piece there, but their oil and Pengrade is another brand of braking oil that I like to use. It has a lot of material to help the ring seat. So going back to this video, you saw when I cleaned the cylinder wall. So when you hone a cylinder wall, you would think you're honing it smooth, and actually it's not. It has microscopic grooving in it. That's the honing lines you see are actually like grooves, and they hone those with a oiled stone. So the grooves will fill up with stone material, and no matter how much you wash it, it takes a lot to get it out. It seems like lacquer thinner is the only thing that really gets it out well. Now, some of the stuff on the rag was from the Foggett oil that I used, because I washed the engine, dried it, and then I used the fogging oil over it because I didn't assemble the engine for 2 more days after that. So you got to protect it. Some people will use WD-40, but WD-40 will evaporate. So this fogging oil is now that I've found that, it is the bomb. And if you have an engine, a car that's going to sit for a long time, fog it, and it'll keep the cylinders and the valves from getting rust while it's sitting. Bill says, good show, George. Thanks, Bill. John says, excellent tutorial. Nice. Thanks. Mike's, you prefer the click type torque wrench over digital? So I do like the click style for rods and mains that don't have torque angle. Now, obviously, if you have torque to yield, you cannot use that style torque wrench. But it seems to me when you're using a digital torque wrench for torquing, that it's very easy to shoot because you're watching the yellow lights, and then it just a little bit more go green, and then you go a little bit more and it goes immediately to red. Where a torque style will actually like clutch. It'll actually go into that click mode and not put that extra amount of effort into it. Thanks, Ryan. Yeah, the count was pretty high. I see 60 views right now. Thanks and thank you for the shout out on Facebook, dude. I really appreciate that. So that's a couple of the things there. You got a clean surface, and you have to have a really good oil so that the rings will seat. The first 3 heat cycles are going to be the make it or break it for ring seal. Now you can go to hidden horsepower videos on here with Lake Speed Jr. and my buddy Joe Costello. They have a lot of stuff. Lake Speed now used to work for Driven, now works for Total Seal, and they actually have a surface tester that will actually show you microscopic the grain and the finish of the cylinders. And there's been a lot of talk and a lot of design changing now with now that they've got this instrument to even make the cylinders finish even better. Now, for everyday build, probably not as important, but if you're building high-end race engines, and you want the ultimate ring seal, then that kind of equipment is very useful. I am relying on my machine shop to do the correct job. I know the 2 shops I'm using currently, I have very good luck with. I've engines that are performance engines that are running 10, 15 years, street and strip, and thousands of miles with no issues. So I rely on them doing the proper job. And of course, me doing my proper due diligence by cleaning the cylinder good and using the proper oil for ring break-in. So with those things, you get pretty good with that. And if you remember a bunch of shows ago, we talked about hardware, and you saw in the video I was looking at the nuts to see which side of the nut had the insignia on the edge to show what bolt was, so that the nuts went on in the correct orientation with the ID marking out, not against the cap. Not that anybody's going to check it, but to me, you're doing your due diligence by blueprinting the engine. You want to care about everything. One thing you probably didn't see or weren't able to see in the video is crazy little things that I have a thing about. All of the freeze plugs were all in the same order as far as the writing was in the right, upside right, and in line with each other. So if you looked at the side of the block, the writing was exactly like it was sitting printed properly. When I put push rods in, the push rods, all the aftermarket push rods will have numbering on them. I put all the push rods in with the writing going in the same direction. It doesn't mean squat. However, to me, it means I'm doing the best job I can personally do, and the next person may disassemble the engine and look and recognize that, hey, this was actually done really good. I paint dot every bolt that I torque on the engine. So when I'm done, the engine's got white or red or blue paint dots on everything. And that is so that I'm telling myself, this was properly torqued, you can move on to the next thing. Sometimes I try not to let phone interruptions or friends and customers come in the shop while I'm doing an engine build. Sometimes it happens. So those are the things that keeps you from making mistakes by not remembering where you were. If I walk away from the engine and I come back and it doesn't have the paint code, I'm going to retorque it, whether it's torqued or not. I'm just going to recheck it, and then I'll identify that it's done properly, and then we know we can move on to the next thing. Yeah, Mike says everything is torque to yield now. Yeah, I think for OEM it works better for them because it's more of a production manner. The funny thing is, if you do use your torque to yield wrench, when you're done torquing it, it gives you a torque spec anyway, how tight it took to get there. And so you always have that window that you can check that they're all good. In fact, I use that for checking bolts. So like if I were to reuse a torque to yield main bolt or a torque to yield head bolt, obviously the manufacturer says don't do it, buy all new hardware. Well, that's all fine and dandy. They're not paying the bills. Some customers are like, hey, let's reuse that stuff. I seen on the internet you can reuse it. So what I do at that point is when I do my torque to yield, when I'm done, I'll read my torque wrench for how much torque it took to get to that degree of angle, and I'll jot them down. And if they're all within, say, 5% of each other, I have no problem. I'm okay with using those bolts over again. Now, if I have one that's way out of whack, that's telling me that bolt is probably giving up and it's probably stretching and will eventually break. So at that point, I would replace that bolt. John says, washer orientation is more important than nuts. You are correct. And that was something in that live show, probably back in the 20 section, episode 20 to 30, somewhere around there, we did a hardware discussion. And you're right. All that stuff has a lot of stuff. The nuts aren't really as far as the right side or wrong side. It's more about being able to look at it and seeing what manufacturer and what temper, what grade the hardware is. If you put it on upside down and torque it, usually that surface will get wiped. And if the bolt nut's been used a couple times, you won't see any identification marks at all. So to me, at that point, that nut needs to be thrown away because I don't even know what it is. Just because it's gold doesn't mean it's a grade 8. But washers have a lot to do with how much, the way it's cut, and the way it bites the piece that it's touching, and then the round side for the nut side. And then if you're using a bolt, underneath the head of the bolt, there's always a radius where the bolt is manufactured. So you want that rolled edge of the washer against the rolled edge of the radius on the bolt. You put it upside down, and it could create a friction point where the bolt might fail. Mike says, "Oh yeah, the torques are all over the place after stretch." Well, I mean, typically I see within about, say, a 80-pound a bolt that's going to be, let's just say, 30 foot-pounds, 180 degrees. Usually you'll see them torqued, like, depending on the diameter of the bolt. But let's just say, for argument's sake, the ending torque is 80. So typically I will see that the bolts will be, say, 78 to like 83. However, when you're doing your sweep, it depends on where you stop. That is key. So I've learned this from aluminum racing connecting rods, that now they're not using torque to yield. However, they are using rotation. So they want the connecting rod, this is R&R or MGP, they want the connecting rod torqued to 70 foot-pounds. We'll just say for on a normal 7/16 bolt on an aluminum rod, they want it torqued to 70 foot-pounds. They want it in one continuous action. So if you have to swing around and stop and grab another click, they want you to re-loosen the bolt and start over again. They want one continuous sweep all the way to 70 foot-pounds. So being I do those a lot, I now have become accustomed to doing my torque to yield in the same manner. So I will start my torque wrench in a certain position so that I can get that whole 180 turn without a stop. Now, if you stop at 150 and then click it and then go to the extra 30, yes, you still went 180 degrees. However, you will see then that the torque at the end will be way different, because there's friction involved in all this, and that's where all the things go. Now, you saw in the video I used motor oil on the nuts for the connecting rods. That's because on an OEM bolt, that's what that torque spec is used for. Now, you go to ARP or an aftermarket bolt, it's assembled with moly. If you use oil, it gets a completely different torque spec than if you use moly. And the whole reason is there's friction in the nut or bolt contact to washer to surface. So that all gets in play with your torquing. So you have to be mindful of all that stuff. Ryan says, checking the freeze plugs is a pet peeve of mine. Yay, somebody looks at what I'm doing. Yay. No, it just, to me, it shows pride in your craft. You're doing something, you want it to be done right. Same with you, Ryan, with all your body work and body fitment and stuff. When you walk up to the truck you're doing, that square body you're doing right now, and all the gaps are perfect, and all the lips and everything are mated, and you just know that the craftsman that did that work cared what he was doing and wants to do the best he can possibly do. And that's what our friends and or customers are looking for. They want the best job. That's why they come back to you. Mike says a continuous swing is impossible on head bolts with an engine in the 22 Silverado. Yes, you are right. There are circumstances that, when you're in car, there's not much you can do about it. And, at that point, that's why your numbers are going to be all over the place, because if you have to not make a full single pass, then you're going to have it. Now, what you could do is you could do 290s, and then you could come back to your every rod or every bolt had the same frictional force when you were torquing it. But that's the I guess the main thing I'm trying to say there is that you want to do repeatability. You don't want to torque one full swing and torque three 45, 45, 45, stuff like that. You want to try to figure out what will work and just do it with all of them. Obviously, line mechanic, time is your money, and I get it. And for doing a warranty type repair or something like that, I mean, as long as you follow the manufacturer's specs, you're going to be fine anyway. I'm talking more of or on a project of your own or a high performance engine where you have to put in the extra work. One thing I really have enjoyed with Doug, now that I'm not at DNR anymore, and he's had to do some performance builds, is he's been on a muscle car, motors don't have a lot of wiring and stuff on them. So he has come to the point now that if he's pulling the heads off or doing any kind of, not major but minor but extensive engine work, he just pulls the engine out and puts it on a stand. That way he has the room to do everything in a good manner. I applaud him for doing that. It may take you an extra hour and a half, 2 hours, but when you're done, first of all, the job is easier to do. It's easier to put the heads on and torque them and just valves and everything when it's on a stand than over top of a fender, especially if the car's got really nice paint and stuff like that. Completely different application than a production dealership type situation. But, it's just one of those things, trying to, put all your care and everything you can into your job to do the best job you can do. It is a great thing to do. So that's our show for tonight. I'm hoping I can get this 8.1 done, and I'm going to do some stuff on the top end. So we'll look at cam degreeing, lifters and checking cam end play and adjusting valves and valve to piston and all those things. We'll see how far I can get with that. Hopefully I can get all that so we can finish up this series. And we'll see how much video I get from Sebring this weekend. If I get a lot of footage, which I'm not very good at typically, maybe we'll do Sebring next weekend and finish up the engine blueprinting the week after. But we'll see. I'll leave that up to next Tuesday around 3 o'clock. I'll know what I'm going to do, and I'll let you guys know when you see the thumbnails come out. So I think with that, we've gone a little over 8, so I go and pull the plug. I really appreciate it. I see we had 64 views tonight. That's awesome. And we had a lot of concurrent viewers. That's awesome. I'm glad that, we had some good tech. I know some of the shows I kind of don't have a lot of tech set up, but I was trying to give you guys some good stuff. You guys are awesome for coming and watching me babble for an hour every Tuesday night, so I try to reciprocate by giving you guys some good information. Rick says, great show, great info. Thanks for sharing your knowledge. Enjoy your week. I appreciate that, Rick. I'm waiting to see some more pictures on that 55. I know it's cold up there, but hey, Chris, yeah, appreciate it, man. So with this, we'll go ahead and say goodnight to everybody. Have a great week. Safe weekend, and we'll see everybody next Tuesday. Remember, give it a thumbs up. It helps the algorithm with YouTube. For the viewers that aren't subscribe. It's free. Doesn't cost anything. You're not going to get any trash or anything for it. It's too cold, right, Rick? And then ring the bell for instant notifications. And remember, share. You have some friends, give them a share link to the video so they can come and check it out. So with that, I appreciate everything. Let me just get everything set up here. And with that, I'm going to say goodnight to everybody. See ya.